It's all right. We got to meet Pam. Pam. Pluggable authentication modules. This is okay. So in a very one-to-one context, if you guys remember, at the very end of your operating systems class, we did a few different policies, right? We set a password policy, the length of it, how many days before you can change it, all that kind of stuff, right? Pam is very similar in nature. However, you can't go into Pam like you can with local policy and set up the way that the start menu works, obviously, because there's no start menu, right? And Pam was created in a time when GUIs weren't as prevalent as they are now. So it really just has to do with security side of all of this stuff. So Pam, really, it's not going to be the biggest topic in the world on this exam. It's not going to be something that you're going to get 7 different questions out of a 60-question test on. You might get 1 or 2. And the type of thing that you're going to be seeing on those questions is not going to be how exactly is it do you change it from SHA-512 to SHA-256 so that we can have reversible encryption on your thing. Like, they don't go that deep. What they're looking for is something like this. They're going to ask you something like, in the above PAM configuration, which of these are module arguments? Check all that apply, right? And so you'll come to the back and say, oh, okay, so obscure and 512 are arguments. SHA-512. Obscure and SHA-512. So it turns out this line has a lot to do with the way that the password is stored. Remember when we looked in the shadow file? And you saw that it was encrypted. It had the little $6. This is where you go to change that. If you want that to be $5, you come into PAM and change that 512 to 256, right? And then the encryption is slightly lesser. Well, lesser by an exponential amount. But, right, this is what PAM does. It sets the rules for security on your Linux machine. So there are 2 places that you go to configure PAM. One is the pam.conf file. Not every machine has one of these, but most do. So you can come into Ubuntu and see if you've got one. I don't have a CentOS box open right now, but if you do, you can check and see if it's present. So cd, or here, let's just do this. Less etc pam.conf, yeah. So if you look at that file, turns out this file actually directs you to another file, or to another directory anyway. It's like, hey, it turns out we don't use pam.conf anymore. Go look at pam.d. Pam.d, that's the other place. So let's go look in SUSE and see if, so yeah, if you take a look, if I do tab here, there is no pam.conf. But turns out that if pamd and any single module lives inside of it, so let's go into pamd here, on a machine that does not have pam.conf, right? And there are things inside of it. If any single file exists in the pam.d directory, pam.conf is ignored. Just straight up, not looking at it, don't care. Won't look at it, won't use it. The whole thing might as well be commented out because Linux will not read pam.conf if modules exist in pam.d, the directory. So in both the cases that we're looking at, OpenSUSE and Ubuntu, pam.d is going to be the requirement, or is going to be where we set up everything. So if we go into etc pam.d, look at all these things. Remind me, what are those bluish looking things up there? GDM-password, little arrow GDM, what is that? What does that mean? There's a blue word, and then it points to another word. Yeah, what does it mean when one thing is pointing to another? I think it was last week or the week before where we talked about permissions and we talked about what that pointer actually means. Anybody? Bueller? Yeah. And what you can think of, so the answer was GDM password is forwarded to GDM. The better way to think about that is look at the L at the very left-hand side of that screen. So L, RWX, 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 right? Yeah, it's kind of hard to see. So right here, that L stands for link. They're linked, soft linked. So soft link, right? That's all that is. So if you're going to configure GDM password, what you really do is you really configure GDM instead, right? And same for LightDM. That's forwarded. That's linked to XDM. So anyhow, just a callback. You can't ever forget this stuff. Anyway, so pam.d. These are all the modules inside of pam.d, and not every distribution of Linux has the same exact things inside of there, but oh yeah, how funny, because it looks like OpenSUSE actually links that to something too, the one we're going to look at today. Pam.d, let's look inside of here. Yeah, but Ubuntu does not. So you can start to really kind of see exactly what's going on with in situations like this, because if you look, common-password is linked to common-password-PC in OpenSUSE, but in Ubuntu, it's just common-password, right? So we're starting to see the differences between some of these distributions, how they decide to do different things. But the thing that they do agree on is that common-password is the file that you will deal with if you want to get in here and change the way that passwords are configured. So if you edit that file, however you want to do that, Nano is the typical way, VI, Vim, any of those, Emacs if you're crazy enough. And then when you get inside of it, you look and find lines like these. But it's not in isolation, right? So let's go look at that. Let's go look at that. All right. Remind me, what does this hash mark mean? All this blue text? What's up with that? Yes, keep that idea, because what that's doing is it's commenting out that line. Meaning, if this configuration file is read in, anything that begins with a hash mark is ignored. So this is the way that you get Linux to ignore things. And it's great for us, right? As a human that likes to know things, we can read all of that text. Right? The SHA-512 option enables SHA-512 passwords. Without this option, the default is Unix crypt. Prior releases use this option MD5, right? So it gives you a little bit of history. It tells you what's going on. It gives you ideas of how to configure this thing. Those comments are great, especially if you're unfamiliar with what it is that you're looking at. Now, if the words inside of this file don't make sense to you, well, that's a different story, and we can go back and learn. But that's the basics. When you get, when you learn a little bit more about Linux, these things start to make a whole lot more sense. Well, anyway, this is the example. And as a matter of fact, this is the default for pretty much all modern Linux distributions. So you can see, like if you have these questions, by the way, what the heck does obscure mean? A lot of times that's going to be directly in the comments, right? The obscure option replaces the old obscure checks enab option in login.defs. But that doesn't give you the full story, right? So what you can do, man pam.d. So remember, man is the manual page, right? Oh, and by the way, I am going off on this tangent for a whole reason. Because if I had to go through every single one of these options and explain every single one of them to you, this lecture would be about 4.5 hours long. So what I'm doing, though, is instead showing you where to get the definition from. Because it's not that easy to go and find this stuff a lot of times. So this right here, man pam.d. And then you can come down here. Scroll down, scroll down, scroll down, scroll down. And you'll find every single keyword. Yeah, it's a lot. You'll find every single keyword that comes up. You'll find obscure. You'll find optional. You'll find all kinds of fun stuff inside of here. So, yeah. So when you inevitably have that question, what does success equal 1 mean? right? That is what you're going to want to check. And this is a habit that you're going to want to get yourself into, right? Going to Google is cool. Easy to just go throw in what is success in PAM.D, right? And then you're going to get this Stack Overflow or Stack Exchange post that has 7 different answers and 7 different ways of thinking about it. And that's cool. There's nothing wrong with that. But know that you don't have to go to the internet for these answers. The answer's right there in front of you. All you got to do is ask the manual. Man, PAM.D. And this works with everything. We're going to look at Journal D later on, and there's going to be a Journal D that we can ask questions to as well. So anyway, password is the type. Control. This is the way that we control how the password works. Those controls exist in this library. So that'll be the module path. This module path is basically, this is the library where I'm going to be pulling out all these options that I'm going to tell you that I want to do, right? So like obscure and SHA-512, right? So obscure is quite literally just to hash it. That way you can't see it, right? If you go look in the files that contain the passwords, all you really get is an obscured password, right? That's what that's about. SHA-512 is obviously the level of hashing that we're doing on that password, right? And so what we want to do, those are module arguments. So the module itself is this one, the thing right after these brackets. And then everything after those modules are module arguments.
Okay, so what you're doing, just so I can kind of get the page, so you're changing the complexity requirements of the password for all users.
Yes, you are changing the well, that's what we're doing in this instance, yes.
So like going to security in Windows, clicking, it's like 8 digits long.
Yep.
Has to have exclamation point.
Yep. And by default, Linux does six digits for a password. It's got to be at least 6.
PAM.D, is that for passwords, users, and groups like Windows is, or does it go more than that?
It is that, and it's more than that. Yeah, so it's more than just dealing with passwords, because if you look through all of PAM.D, that directory, you see all kinds of stuff, right? Rules on how to create new users, rules on how sudo is used, rules on how systemd can be taken advantage of, rules for adding groups. So it has to do with security more so than it does with individual users or anything like that. It's just that in this case, we are affecting every user with the change that we're making. So what we're after in this instance is I want to change the password requirement from the default of 6 to a minimum requirement of 10. Your password is going to have 10 things. Now, this was, go ahead. That's not what we're changing. All we're doing is, because this is the same as this, except we've just added that. Yeah, okay, yeah. So that's what is default in pretty much every Linux distribution at the moment. If we add one single module argument to the end of this, all we got to do is add a space between SHA-512 and the new argument. Then once we save that file, it happens automatically. There's no restarting a service for this one. Every time you do anything on the system that has to deal with security, PAM is consulted. And if there's no rule on it, then there's no rule on it, right? It's whatever the Linux default is, or there is just no rule, right? There's nothing to follow. But if PAM is consulted and there is a rule on it, that is followed every time. And it's checked every time you do it. So because we're messing with passwords, and then we add this module argument to it, minlen 10, minimum length of 10, then the next time a password is created, has to be 10. Doesn't matter if you logged in, logged out, rebooted, nothing. The moment we save that file, it's in effect. But it doesn't work backwards. If your password has 8 characters and then we change PAM to minlen 10, then at that point, your next password has to be 10, but your current password can remain until it expires. Right? So it does take immediate effect, but it doesn't affect already generated things.
Could you go a little more in depth on the mod path? Because I'm not understanding how that works.
This basically just exists in like userlib or in lib. These are libraries. PAM Unix exists on the system somewhere. Should be able to find it with a locate. Let's see, locate.
So that's what you're modifying is PAM Unix stuff.
Yes. Well, yes. So in the first case here, you're saying I want to use this module. This module is the thing that I want to use. There's a library out there that knows about all of these different things that you can do, like as in set a minimum length for a password. And that is in lib64, security, and PAM Unix. And you can man it too. I think it's just PAM Unix, yeah. So if you're like, okay, well, what are all the different options that I can put with that, right? No delay, auth talk. There's that SHA-512. You can use Blowfish or BigCrypt or all these other different things. There's Minlin right there. Set a minimum password. Here's some examples of how to put that together. This is really what I want you to pull away from this. More so than I want you to remember minlen equals 10. I want you to remember that you can man pretty much everything that comes up in this situation, right? You can man PAM. You can man PAM.d. You can man every single module that you might be able to use in the context of PAM. That's more important and more valuable than remembering how to increase the length of a password requirement, something like that. But so PAM_Unix.so in this case is a library that is installed on a system that knows all of the rules about passwords, about Unix-style logins. And within that library, there are these things. No pass expiry, right? If you never want passwords to expire, add that option. Add that module option to the end of this file, which lives here. These are the password rules that are common to every user, which is where its name comes from. Common password. The common password rules for everybody. So, go ahead. Yes, it's in every Linux distribution. Every Linux distribution. You pull in Unix, you pull in PAM. PAM has been around for a very, very long time. Now, there are different ways to deal with this, right? PAM has a module that will allow you to prevent people from logging in multiple times with a failed password, right? And it'll just lock you out. Even the book talks about this. There's a command called fail lock to keep an eye on these things. But there are also other ways of dealing with this. There's a software called fail2ban that'll do it for you. So in a lot of cases, the usability or the things that PAM does have already been recreated with other packages, right? PAM got very big and very unwieldy. So there's a gajillion different options in a gajillion different places. Think of group policy, right? Have y'all messed with group policy in Active Directory yet? Right. Have you seen the sheer magnitude of policies that are available to you? Yeah. PAM is the same way, where when you think, all right, I've got this one idea about, taking care of my users and deleting users after a certain amount of days or whatever. And you think about that and you're like, I wonder if there's a PAM module. The answer is yes. There is a PAM module for that. There are options for that thing that you want to do. The problem is there's not going to be some blog post by some guy that wrote it up because it's just not something that a lot of people end up doing. You don't delve that far down into PAM and then think the first thing that you think is, I should go write a blog post on that, right? You get it done because it's part of your job. It's enterprisey. You turned it on. Everything is following that rule set now. Okay, cool. Move on. You don't write a blog post about it because man pam.d exists. The blog post is already written. It's just not on a blog. It's in the manual. So it's once you get down convoluted enough in PAM, your best bet is to check this man page for why this works, how this works, what the definition of obscure is, all that kind of fun stuff. So anyhow, didn't mean to get too far off that, but it's all relevant. It's all relevant. Anyhow, okay. So that's PAM. Know that this first set is what you're affecting. We're dealing with passwords. Second set is how we control that. What does success mean when you're given a password? These are the modules that we're pulling in, the libraries, the things that know about other things, right? They're all the rules are defined in here. And then we tell it what rules we want to use right here with these module arguments. Pro tip. On the test, this is what they're going to ask you about. They don't care if you know min, len, 10. They care if you know what the difference between a module argument is and what a module is, and what the control is, and what the type is. That's their main focus. So general PAM information, not how do you set a character length to 10 on a password. Okay. So SSH. This one's a fun one. This one's a real fun one. What's that? Secure Shell. Yes. So what is Secure Shell? It is the command line alternative to remote desktop protocol. Right? Have y'all used RDP yet in Windows? Yeah. Oh, yeah, I've forced you guys to do it in the end of operating systems, right? So imagine doing RDP, but all you get is command prompt. That's Secure Shell. But better, Secure Shell, I mean, this is more, Secure Shell is open source as opposed to RDP, which is closed, which means that Secure Shell can be audited by anybody in the entire world at any time, which lends credence to its ability to keep you secure, right? It's kind of in the name, so it kind of has to be there, right? Well, Secure Shell doesn't have the issues that RDP has. As in, if you expose RDP out to the internet, sorry, your box is probably going to be owned within the next 24 hours. Secure Shell is not like that. Can be exposed to the wider internet, and there are a lot of different things that you can do to secure up Secure Shell. So, if you want to make a change, and this is why, especially with that fish conversation that we were having last week, if you want to be able to get a remote shell into any Linux box, I guarantee you it's going to be Bash. So be aware. Bash is what you want to learn, and that's all you need to know to get access to any box and do whatever it is that you want to do. You know, our web server that is set up on multiple Dockers across the world, multiple containers across different cloud service providers, right? We have 100 containers running this web server in Google Cloud, 100 containers running it in Amazon Web Services, and 100 containers running it in Microsoft Azure, right? And they're all being puppeteered by a Kubernetes instance that we host locally or something like that, right? But you need to be able to restart a service, right? Just because it's all puppeteered and maintained and all stored up in Git and whatever, sometimes you just need to simply restart a service. So you need to SSH into a machine, restart the service, voila, everything's working again. So SSH really shines when you need to be able to get access to a box that you are not physically in front of, right? So how do you do it? In the most simplest form, it's that. SSH space host. And I have it italicized because host is not literally what you type. You type in the IP address, or you type in the host name if it's resolvable by DNS, or if it's in your Etsy host file or something like that, right? If you can call it by name, if you can say ping my server, and my server resolves to an IP address and you can ping it, you can use it with SSH. If you cannot resolve it, use its IP address. So what that means is SSH 192.168.10.1, right? Hit enter. If it responds to you, it won't. But if it responds to you, then it will come back with a prompt. And it'll just say password. What's the password? So this gets a little complex. Because when you do that, it assumes, if you don't specify, it just assumes the user that you want to log in as is you. So if there's a Leo account on the box I'm trying to get into, then it will just assume that. It'll assume I'm doing Leo at that machine that I'm trying to get into. So that'll fail eventually. So what you want to do instead is specify the user. So let's say it's admin at. It looks kind of like an email address. So if I'm Leo on my current box, but I want to log into admin on a different box, this is how you would type it. SSH admin at the host name or the IP address that you want to get into. That's the deal. But that's it. That's how you log into a server remotely. As long as you have the password, you're good to go. There are more steps, by the way, than just password that we'll get into a little bit later on. I force you guys to do it in the schedule's changed. So I normally have you guys do it in the 4th semester. Guess what? 3rd semester. Yay. Security goes in 4th semester. So we've made a swap. That class tends to hurt a lot. So, sorry.
So when you sign in and you're successful,
Uh-huh.
what do you get? Do you get a command prompt on your machine, or do you get, like if the server has a, like your SSH into something that has a GUI, and you get the GUI?
You can. So the question was, if you SSH into something, what do you get? So if there is no GUI on the far side system, all you get's a terminal. Now, if there is a GUI on the far side system, and X11 forwarding has been enabled in the configuration file, which we'll look at in just a sec, then you can quite literally, as long as you have X Windows on the local machine, you can basically just type in Firefox and poof, Firefox pops up. But it's not your Firefox, it's Firefox on the remote machine. So yes, in both cases. You'll get a prompt if all there is a prompt, and actually in both cases you'll get a prompt. But if X11 forwarding is on and you have X11 on the local machine, you can type in a GUI name of an application, or a name of a GUI application, and it will pop up on your system. So that totally is a thing. You can do both. I used to do VM administration that way, where I was on a Windows machine, but the far side machine had KVM on it, and there was no way for me to install what was called Virt Manager. It's basically the GUI, right? So think Hyper-V when you're getting into that and you have the right click and all that stuff. There was no alternative for Windows, so I installed, what was the name of it? Xming. So it's an X server for Windows, and I enabled X11 forwarding on my server, on my Linux server, and then I just typed in, after I SSH'd, Virt Manager, boop, my window popped up from the Linux box. It looked like Linux, it felt like Linux, it was Linux, but on my Windows machine. So X11 forwarding is really, really useful. But there are better ways to do that now. There are better protocols than SSH and X11 forwarding. But in a pinch, it's fantastic. You don't need anything extra for it, unless you're running on Windows, in which case you need a lot of extra stuff. But if it's Linux to Linux, it just works. It just pops up Windows. Okay, good. Yeah, I've run into that situation so many times. Totally can work. Now, what's funny about this is, check this out. This is a Windows command prompt. 2019 is the year of SSH. That's when Windows added it to the command line. It has existed since the 80s. Well, late 90s for sure. But Windows finally caved and added it to their system. So, really cool.
You can SSH from Windows to Windows.
Yes, sir.
Windows to Linux.
Yes, sir.
Linux to Mac.
Yes, with caveats. Yep, absolutely. So the cool thing is now, SSH is the universal protocol. Everything supports SSH. That stupid, dumb Cisco box that you have that doesn't do much other than just send packets back and forth still supports SSH.
So you can SSH from Windows to Windows. Will you get the GUI? So
So with caveats there too. You have to install, I don't think this is SSH server. I think this is just an SSH client. If you want to SSH to Windows, you'll need to install Windows Subsystem for Linux, which is basically you pick a distro, you install it on your Windows desktop, but it's basically a Linux shell, and you can SSH into that. So yes, but yeah, not directly. You got to add a little bit of flavor to Windows before you can actually SSH into Windows. However, Windows has its own language. It's got WMI, Windows Management Interface, which allows you to run PowerShell scripts remotely. So they do their own thing. But here's the thing. Linux supports PowerShell too. So that means that you can install Windows Subsystem for Linux, SSH into it from a remote location, run PowerShell, and then execute PowerShell commands. So yeah, it's all crazy convoluted now. But yeah, SSH seems to be the universal language that everybody speaks now. Finally. 2019, Windows came on board and created Universal.
Basically what, and I don't want to go too far off of that, but is that basically what that TeamViewer does?
TeamViewer uses, I don't know what protocol it actually uses. It may be their own proprietary. Yeah. Except for the multiple times that they got hacked. So yes, they cannot see the data in transit, but it's a remote protocol very much like VNC. So we don't talk a whole lot about VNC here, but yes. It is a remote control protocol very much like VNC and X11 forwarding. So yes. Yes with caveats, right? But yeah, that's the idea. It's just a remote control protocol. All right. Yeah, and then don't forget, y'all can do Discord sharing and stuff too, so you get chat alongside it and all that, right? So there's a lot of ways to do that. So anyhow, that's the deal, right? So SSH username at host is typically the way that you're going to be doing this most of the time. If your username matches, you don't need to put the username there. SSH and then host. That's all you got to do. So you want to change the way that SSH works. Well, that is one file, and it lives there in pretty much every distribution of Linux. So if we less etc ssh sshd, oh wait, oh you know why it doesn't exist? Not yet, right? Does not exist, and that's because my Ubuntu machine is not accepting connections over SSH because I don't have the daemon installed. I don't actually have OpenSSH server installed. In OpenSUSE, you do. When you install, here, let's just do that. When you install the SSH package, as we did a few weeks ago, it installs the server automatically. The client and the server are all all part of one package in OpenSUSE. So that means that if I go in there, SSHD config. What is that? Is that a file? A directory? What is it? SSHD config, that very last thing on the bottom of that list. Is it? What? It would have a D at the very beginning if it were a directory. It is. Look at that dash. That dash before the first R. If it's a dash, it's a file. It's probably a text file. Yes, sir. Ah, see, okay. So D in this context in SSHD stands for daemon. So if we less that file, oh, then you can see these are the rules that anybody connecting to this machine have to follow, right? Less is just show me the text in a interactable way so I can keyboard up and down. And then in the comments are the default values. So if it's commented out, it's still using that anyway. Not because it's reading that line and applying that, but they're just showing you what the default value is. So if you uncomment that, doesn't actually mean anything. you'll have to change it too. So like say down where it says port 22, look at the very top line now. Very top line. Port 22. What does that mean? Is that the default port for SSH? It sure is. So port 22. So if we uncommented it, it wouldn't actually have any effect, right? We would have to say, oh, port 23. We'd have to uncomment it and change that 2 to a 3 to get 23. And then that would be the port that it listens on, right? So these are the rules for SSH. One of the rules that you always, my God, I don't know why it's not a default anymore, or why it's not a default yet. Rules that you always want to change, and actually let me get into this instead of lessing. Let's do nano. And the reason I want to do nano is, just kidding. It does it in Ubuntu, but it doesn't do it in OpenSUSE. Great. Let me just do this in Ubuntu. Let me show you why. Yes, color coding. So let me ask you a question real fast. How do you install software on an Ubuntu machine? Sudo what? Yep. Yep. And the package we want is open SSH-server. Right? We had open SSH-client installed, obviously, because I can type SSH and get help and all that. Would have. Yep. I'm a paranoid kind of guy, though. Really? Interesting. It definitely works in Ubuntu because I know I do it all the time, but I tend to wear a tinfoil hat all the time. So that means that I tend to run without the -y. That way, because I feel like if I just do Y, then if I make a mistake or whatever, I can't stop it. But at least with if it asks me, I'm like, I can for a split second sanity check, right? All right, so, oh, there it is. Okay, so now we have an SSHD config in this directory. Much better. Color coding, right? All the blue stuff is ignored. So we come down here and we see, oh, look. In Ubuntu, it is the default. My God. OpenSUSE, what are you doing? There. Right? Must be. So, the default in Ubuntu, if we were to permit root login, what does that mean? Permit root login. What do you think that option means? Right. Can you log in as root over SSH? Only over SSH. This affects only SSH. So are we permitting root login over SSH, right? That is a horrible idea, right? But in this case, if we were to uncomment that particular line, then it would say prohibit password. That option means, yes, you can log in as root, but not with a password. But that begs the question, well, how else do you log in? We'll get to that. Hang on. So, but in OpenSUSE, my God, did you see that? The default was just yes. Yes, permit root login. No, do not. No. Seriously, don't do that. That is a bad choice. Bad choice. Same, thou shalt not. Ooh, hey, there's another commandment. Thou shalt not permit root login over SSH. Period. You really shouldn't in any way, shape, or form. But if you do, the Ubuntu default is the sane one. Do not permit passwords. So the alternative to passwords is keys. So you'll generate keys. You have a public key that you place everywhere. You would put one on this server, and then you would hoard your private key like Gollum from Lord of the Rings, right? My precious, do not ever let it go, right? The moment someone gets your private key is the moment they can log into everything as you, whenever they want to, however they want to, from wherever they want to, right? So that private key is extremely precious. It's not a Kerberos thing. It's more just a cryptography thing. You have this public key cryptography. We were talking about breakable passwords. Not a breakable password. We do not have the technology to break those things in any kind of reasonable amount of time, right? By the time you break that password, we have changed it about 12 times, right? So anyway, so you have this key. You want to keep it safe. You want to keep it on an encrypted flash drive or something like that in your pocket, on your person all the time. You never leave it alone, right? It's important. Same with your keyring, right? If you have a Grandmaster key to a building that has millions of dollars worth of equipment in it, you don't just leave your keys laying around, right? Same deal here. You don't just leave that flash drive with that key on it laying around. So that's what this means. Permit root login, yes, just means that, yep, root can log in however he wants. Permit root login, prohibit password means you got to use something else like a key. Kerberos is also another way to do that. But root shouldn't have any kind of LDAP identity. So 99 times out of 100 just wouldn't work. So keys are really the way to do this. Now, you know, I think we're just going to have to do this right now. I usually try to wait for most of the crazy demo until later. Let me just ask you guys, what do you guys feel like? Since we're talking about SSH, you want me to just demo it now? Or do you want me to wait and demo everything at the end?
I'd like everything in a video kind of back to back.
Okay, cool. All right, so let's do that. All right, so this, so we're gonna kind of do this not really out of order, but out of the normal order. So in the lab, I have you guys down here in OpenSUSE actually coming down and configuring your VMs to use NAT networking, so that two VMs can speak together, but they still have internet, right? So we're gonna have to go through a little bit of the build up to that, but that way it all stays together and sane, and you won't have to skip through the video a bunch. Okay. So NAT network. So you guys know what NAT is, as far as, well, I'm sorry? Right, so so each of your VMs is defaulted to just the network adapter of NAT. That basically gives you one IP address. It is the only IP address, and you go straight out to the internet. That's how it works, right? Translates you all the way out so you have an internet connection. NAT network takes that one step further and says, yeah, all that stuff, except I want more than one machine behind this NAT. So it still lets you have internet. It still shoots you straight out, but you can ping other things within that network. You just have to put things on that NAT network. So here's the deal. Yes, we did. We did. So y'all aren't totally blindsided by this, but just a refresher, this is how you do it. File preferences, go to network, create a new, wait, there it is. Click on the little cogwheel or double click on the name, and just make sure it says something. Doesn't really matter what it is. So this is gonna be Linux Plus. You don't have to change the IP addressing on this. I tend to like to do that. And make sure supports DHCP is on. We're not to the chapter yet where I show you how to configure static IP addresses. So DHCP. Hit OK. Hit OK. And we should be good. So if you go into each of these VMs, into the networking of each of these VMs, notice that it is NAT. You can swap it down to NAT network, and it should match the network that you created. Nothing shows up here until you create a network first. You have to do it in the order I did it. Unless you already have a NAT network, which you may.
That's what I was gonna ask.
Okay. Feel free to use it. I don't care. Does not bother me how. Just make that network work. I don't care about the details. As long as it works. Hit OK. That'll change. Do the same thing on OpenSUSE. Because I think in the lab I'm having you do OpenSUSE to Ubuntu. So how I installed the OpenSSH server earlier, you'll have to do that as well.
Sudo apt install SSH.
Yep, and it was the package OpenSSH-server. Yep, and by default, it turns on, it's listening, and it's enabled. So you're good. You don't have to do much more than install it. So at this point, you'll notice your IP address probably didn't change. So you've got to force it. What's that? Yeah, so you can do this a couple of different ways. A lot of times just a restart of the networking service will take care of that for you. So sudo system control restart network. I don't know if it's network or networking. I always forget. Maybe? Ooh, I know that works on Ubuntu. Let me see. Oh, it's still searching. There it goes. Network.service. Okay, it just took forever. All right. So sudo system control restart network.service. Remember that if there's only one by the name, you don't have to type the .target.service. Whatever. You just hit enter on this. Maybe? Oh, man, I hit tab too many times. Look at that. It's still going. So same. Oh, this one doesn't have one. Ah, interesting. Well, I'm going to show you a bunch of different ways to do it anyway, so it's no big deal. Network. And then IPA. See, it still has the same. So you're going to have to do it the same way on both. So sudo DH client. We'll start the DH client service. And then sudo DH will release your IP address. And then running it again should ask for a new one, a new IP. So this is the equivalent of ipconfig/release, ipconfig/renew.
Would you get the same result by just restarting the machine?
Yes. But that's the easy way out. If the server that you're running on has multiple network cards and it's hosting a multi-million-dollar website per minute, probably don't want to reboot it. So be aware of the way to do this without rebooting it. Reboot it for time's sake, for whatever, but know the right way to do it. Take a look at that IP address. Let me add some color to it to make it a little easier. Well, the pink. Look at the pink.
So you have to do the DH client before you do the DH client?
Yeah. Yeah, because the networking service is typically taking care of the IP address gathering right when you boot up the system, not DH client. So the first step is wake up DH client. Then the second step is to drop the IP address that you currently have. And then the third step is get a new IP address lease. Yep. So it is a 3-step process. It's kind of dumb. I don't like the way that works, but yeah. DH client R, DH client. You'll be good. Same with Ubuntu. Sudo DH client, wake it up. Sudo DH client R to release it. Sudo DH client to get a new one. Oops.
So IP is the same as an IF.
Okay, so yeah, so the question was about IP. The reason I did IP was because I had to do it in OpenSUSE. If you look, OpenSUSE 4-star hand. If I type in ifconfig, command not found. ifconfig has been deprecated for about 12 years. It has finally started to drop off distributions in favor of IP. So, oh, no, of course. Yeah, well, it's in your books because it's still in distributions. This is the most current version of the Ubuntu server. It has ifconfig. So it's worth repeating that ifconfig is a proper way to do things, but with the caveat that in Ubuntu 2004, might disappear. It might not be there. So be aware that IPA will get you the same basic information. And most, no, I don't have it on here. Yeah. So, but you can do this, right? In MCLI, in some distributions, in MCLI Dev Show will give you a bunch of information about your particular devices or whatever. But not every distribution uses Network Manager. So the base knowledge that you need to have to figure out what IP address you have is IP space A. Oh, add the -C option, like that? Yep. No. Unfortunately, the colorization does not work with everything, but for a lot of things it does. Yeah, I know. Well, a lot of Bash gets it colored for you anyway, without you even thinking about it. Because LS doesn't actually have color by default. It's just alias to the -- colorize option. So, yeah, it does it by default. You just don't realize that it's doing it for you. Okay, so we have our IP addresses, right? 10.10.10.6 on Ubuntu, 10.10.10.5 on OpenSUSE. So, how do I do this? SSH? I want username and host name. How do I write that out?
Admin,
Well, Leo in my case.
Leo,
Mm-hmm.
space password.
Number one, never type a password in the terminal. Not directly, not on the command line itself. It'll ask you for a password and it'll obscure it. That will be the easiest way to deal with that. So SSH Leo, but SSH into what?
At IP address.
Yeah, 10, 10, 10, 6, right?
It'll ask you for a secure password after you shell it.
First question it asks. Hey man, this is a new guy. I've never connected to him before. Are you sure this is safe? So basically what it's asking you is, do you want to accept this key, this fingerprint? And what it's going to do with that, it's going to write that down, and the next time you connect up to it, if that fingerprint is the same, it'll just let you connect. But if that fingerprint ever changes, which is like the tamper evident seal on the milk that you open up before you drink it, right? You want to know that someone's tampered with that before you actually try to drink that milk. Same deal here. If that fingerprint changes, as in there are any systemic changes to the system before you connect up to it again, it will tell you, hey, this fingerprint doesn't match up to the last time that you connected up to this machine. Are you sure you want to do this? Yeah. So that's what this is about. You'll only ever get this question, hopefully, once. If it ever changes again, you better think twice about hitting yes. Well, actually, it doesn't even let you hit yes. It tells you to go delete the old one so it can accept the new one. So there's a bit more of a process to it. So anyway, we just built this machine. I've been the only one that's been in front of it, so I'm confident that I'm okay to do this. Hit yes. Now, it tells me, yep, I've added it. And the next question is, what's your password? Ta-da! Now what does it look like? Leo at what? UBU. And that's the same as this.
So Leo is a root user, right?
Leo is a user that exists in the sudo directory, which gives me sudo access.
Technically, you are logging in as a root user, right?
No. I'm logging in as a user that has sudo privileges. There is a huge difference. Root doesn't have to ask for permission for anything. It can just do whatever it wants. Leo has to present sudo anytime it wants to do anything that requires privilege, and on top of that, unless I make changes, have to present my password. So the account is not admin, but I can take extra steps to do things as an admin. So it's like in Windows, you're really not an admin even though you're in the admin group. Anytime you try to do anything that messes with the system, pops up with that UAC, yeah. And on systems with Active Directory, you have to present your password. You can't just click OK, and everything's going to be hunky-dory. You have to do that. So I am connected to the remote machine. How do I know this? How do I know that I am connected to a totally separate machine? Well, look, at the very top it says, welcome to Ubuntu 1804.3, right? But I'm in my OpenSUSE VM, right? So who am I won't help me a whole lot here because I'm Leo on both machines. But hostname will, right? Hostname Ubu. Same over here. So this VM, whole machine, is remotely connected to this machine.
In this, just as a virtual box, could I remote into Ron's if we had it?
Can you do what now?
Can I remote into his computer from my VM
If you are on the same network.
if we're on the same network?
Yes. So this is why we make you guys slog through Cisco and all of that other stuff. SSH doesn't mean jack if you don't know how IP addressing works. If you don't know how basic networking works, right? So yes, you can connect to a box in China, but you have to have a route to that box. So routing comes in extremely handy. IP addressing comes in extremely handy. Subnetting comes in extremely handy in situations like that. So,
So I got a question.
sure.
If I try to I almost came out wrong. If I try to SSH into your server,
Mm-hmm.
and I put in like, that, as, like, well, I want to log in
Uh-huh.
but Batman doesn't exist.
Mm-hmm.
What would be my reply from that source?
Well, let's just find out. The best way to do this, I can tell you till I'm blue in the face, but if I show you, it might stick a little better. So let's find out. So this is my OpenSUSE box. To close an SSH session, all you do is just type exit. And now, look at that. Connection closed. Now I'm back on my HTTP server Bangladesh. I don't know, that's what I named it a few days ago with the hostname command, right? Right, so now I'm back on my local machine. So you said you wanted to find out what it would say if there was a user that didn't exist, right? Try to log in with that. So SSH, Batman, 10, what was it, 5 or 6? Oh, 6, yeah, 6. So SSH, Batman, right?
Someone's asking you for Batman password?
Yeah. You think I'll ever get it right?
Because he doesn't exist.
That's it. If Batman exists, then yes, maybe one day I'll get it right. But the whole thing with Linux is that why would it help you? If you don't know the users on the system, why is it going to take that extra step to help you enumerate the users on the system? It's going to surely just let you keep hammering away at it.
You know, I was super great asked that question, but that makes a whole lot of sense.
Yep. And then in Ubuntu, what you can do, var, is there an SSH one? No. Var, it's probably under auth log. Oh. What? Huh. Let's try that. Sure enough, it's not logging it. So there are typically files. The auth log. We're going to get into that actually. What's that?
It actually says that we're,
Oh, did it?
well, maybe I'm looking at
Yeah, that was the previous one. So it's not logging failed. So we might just need to tell it to log the failed stuff. Oh, does it?
That's a session with 10 right above where you are.
Mm-hmm. Oh, I totally see it. Yep. Okay, I'm just blind. I'm glad you had eyes for that. Yeah, so you're right. You're absolutely right. So the log will actually have it. Invalid user Batman from 10.10.10.5. Port that.
Oh, it logs where it came from.
Yep. So the whole point of all of this is that no, it's not going to help you enumerate usernames from the far side, but for you as the admin of the box that's being brute forced, you'll know about it. You'll absolutely know about it. But guess what? The next section is all about logging. I brought that up because it's next. So anyhow, so some of the cool things that you can do with SSH though is, so let's do this. So in my Linux machine, ooh, look, I've got file 1. Let's do this. How about we're gonna nano secret file is the superest secret. Okay. Totally valid English sentence, right? All right. So I've got this file, super secret. Here's the deal. The last thing I'll talk about on SSH is that you end up a lot of times creating files. Or you need to move a file, right? You have the script on your machine and you want to push it to that machine so that you can run that script. Or you can do something, right? And it's not in any kind of web gettable format, right? It's not on a web page that you can go download it with wget or curl or anything. But you just have this file and you want it to go over there, right? You can do that with SCP. Newsflash, SCP also deprecated. Matter of fact, if you go to SCP's website, right up at the top, big old banner, stop using it. And it says, go use SFTP instead. So, for the test, SCP is the secure copy command. Uses SSH, but it has accumulated flaws over the years. And instead of updating SCP, a whole new project, SFTP, was born that fixed all those issues and then some. So, SCP is recommending SFTP as the successor to it. So, the beautiful part about SCP and SFTP is that the only difference between the two, outside of the underpinning it's better, the command structure is identical. So if you learned SCP, you already know how to use SFTP. If you learned SFTP, at least for the purposes of this test, you know exactly how to run an SCP command or an SFTP command. They're interchangeable. Secure copy. Yep. I think CP is just like CP as in copy. Yeah. Because it's using the SSH protocol. So I don't think the P in there stands for protocol. However, in SFTP, it does. Secure File Transfer Protocol. Yeah. So in this case, it does not matter if I use SCP or SFTP. Unless, of course, SCP or SFTP doesn't exist on the system. But, like for us, both of them exist. All right, so here's the deal. Here's what I want to do. I want to take that secret file and move it to my machine. Right? Okay. So let's do this.
Did you make the secret file a secure file already?
No, there's no permission that I need to worry about or anything like that. Yeah, I'm more concerned with showing you how SCP works. So let's focus on that. So SCP, and you want to do what? I want to, it's just like copy. From where to where? So I'm on OpenSUSE. The file is on Ubuntu. So the from where is going to have to include the remote resource, right? The remote host. So the first thing I want to do, it's backwards in this example, because you can push or pull files. It does not matter. Just the order is the only thing that matters. So this is an example of the remote resource. Right. So in the example, it's root, but in my example right here in front of you, it's going to be Leo. So, yep, Leo at, oh, no, well, 10, over here, I would log in as Leo. That's what matters. The remote resource matters. So if I'm logging in as Leo over there, I just need to type it out. So if there was an admin account and that file was stored in admin in its home folder, then I would type in scp admin at. It just depends on the username that you're. Uh-huh. Yep. And then colon. This is going to be, all right, so the remote host, and then this is the file I'm talking about, and separated by colon. So, home, Leo. No space. So it's called secret-file. Okay? Yes, now space, because we're differentiating from where from its to where. So from where, the remote computer in the home directory inside the Leo directory in a file called secret file. Nope, because I'm on this local machine. I don't have to present any kind of identifier or anything like that. But, I want to stick it in right here, but to get away from using shortcuts. Home Leo. Yeah. But that looks kind of weird, so let's just put it in temp. How about that? Did it go? Yeah, it didn't yell at me. It actually did tell me some stuff, though. It told me how fast it came. 100%, 41 bytes, 43 kilobytes per second. Took 0 seconds. Pretty quick, right? So, let's go into TMP and verify. Secret file. Secret file. No? Nobody? Anybody? Somebody? Yeah, secret tunnel? Yeah? No? Anyway. So, let's, let me prove it to you. Remove secret file, get back into my home folder, take that scp command, SFTP, right? Proof positive. SCP and SFTP are backwards compatible. Ta-da! Works just fine. So it's in temp as well. What's that?
Did you not change anything to change it to SFTP?
Nope. The only thing I changed was SCP, morphed that into SFTP. Everything else was exactly the same. So I'm just showing you. I'm sorry? Oh, I deleted the other file prior. Yeah. But actually, I don't know. Let's see what happens. What happens if I do it again?
Should be redundant.
Fetching home Leo. I wonder if it just updates it. I don't tend to do this a whole lot. Yeah, I just updated it. So yeah, it wrote over the current file.
And didn't ask for override.
Mm-mm.
It's the same, you don't, all right.
Yeah, you said it. You told it to do it.
So you can copy it on your group directory or something like that. Okay,
Yep.
good luck.
Yep. You told it. Yep. You told it. You told it to do it. Now, you don't typically run SSH with pseudo privileges or anything like that, so it's not like you could really overwrite system files like this or anything. But I mean, yeah, certainly in if you've given yourself permission to do so without the access of having the need to do sudo or something like that, then yeah, I mean, you can blow it up. You can totally blow it up. Yeah. So there are other options. rsync. rsync again works exactly like SFTP. But the cool thing about rsync is there's a ton of options that take into mind and take into account the fact that people want to back things up sometimes, right? As in, I want this to happen every single day at the end of the day and then back it up and back it up and back it up. Heck yeah, every day. Yeah. I know, right? Who does backups? You want to keep that job, you have yourself a backup. So rsync has flags in it that says, hey, check for that file in the destination to make sure it doesn't already exist. And if it already exists, then ignore it. Don't copy it over, right? So because rsync, right, remote file sync, means that you're downloading these files. And as far as bandwidth is concerned, if you don't need to download it, you don't want to download it. So rsync has flags in it that will allow you to say, all right, if the file exists, don't download it again. Especially if you're trying to sync up image files, right, that are massive, right? So rsync really, really excels in that. So SCP, deprecated, but it's on the test. But the best way to do this is learn SFTP and just remember SCP has the same command structure.
So on rsync, if you have multiple files and you've already downloaded them, does it go off of if it's been touched? Then it will update it?
Yeah, it actually has a flag to look for dates as well. So if the date matches, it won't update it. But if the date doesn't match, but the file already exists, it will update it, right? Because obviously, if you want a backup, you want the most recent versions of all the files. So yeah, works off date. Now, the difference between SFTP and rsync, SFTP excels at one file at a time. rsync excels at directories. That's the big difference between the two.
So if you, just as an application to this, so if you are on like a RAID, right, RAID,
Mhm.
you want to rsync address dot, like the home folder, everything, you do that?
Yeah. Yep. rsync will pull the whole directory down. That's the whole idea. That's why it exists. Its precursor was RCP. Getting a pattern here? SCP, RCP. Yeah. So those both are deprecated. SFTP is the single file way to do things. rsync is the directory way to do things. And those are the ones you'll need to know for real life. For the test, SCP and RCP might show up. All right. So now that you know all of that, I want to try and blow through this because we got about 20 minutes left. Yeah, I said I was going to start at 10:45, and I didn't actually start until like 10:50 something. So yeah, anyway. So date and time. It's really important that you know what the date and time is, and that your system has the correct date and time, and that you know how to update it or use it in the case that you actually want to mess with stuff. So here's the deal. Date. Just type it out. Bingo, bango. There's the date. Right? You probably want to do this maybe once a month or two to make sure that your clocks are actually synced up, right? If the date is way off, that journal that we were looking at before, where was it? Right here, right? Said something about, yeah, like this. Look up toward the top, says a session with the ID 6 has been terminated, like right up here. February 25, accepted password from Leo. When did that happen? 6:03. Do you see that? So if the date and time is wrong, you get a really skewed version of the events, right? So we need the time to be correct. So if we do date over here, it's wrong. few hours ahead.
Yeah, my stuff is like that too, because I'm always saving state on my
Oh yeah, a reboot will typically fix that, but let me show you the real way to do it. So turns out, if you want RFC 2822, so there's an RFC for everything. Every rule there is on the internet is quite literally written down by a bunch of nerds, and I love it. If you ever want, for lack of a better phrase, toilet reading, this is fantastic stuff. It's boring. You want to get out of there, right? That's the whole idea. But quite literally, this is their thought process. You ever wondered, back in 1978, when that very first rule got written about the internet or whatever, and you want to know what their thought process was, why did you call it that? The abstract probably has the reason why they called it that, or the reason why layer 1 and layer 2 are separated the way that they are, or the reason why we chose 32-bit numbers for IPv4, or why we chose 128-bit for IPv6. You want to know that thought process? It's in the RFC. Every single reason for every single thing, whether or not it's a good reason, is there. So, this is quite literally the internet message format, and it defines how you write the date, and that date is written like that. That's what? Date refresh? Oh, I don't think so. I think it's actually R for RFC. Yeah, RFC email. So messaging. R for the RFC way to do it. So let's say you want the current time of, I don't know. Let's look at that. So if you look up, this is the way that you're going to actually write it out. So date plus, and you're basically just manipulating the way that date is going to display you the information, right? You're not changing the date or anything like that. You're just telling date to, hey, give it to me in this order, in this order, in this order. Put some commas in there. Some dashes are cool. Maybe a colon or a semicolon or two, however you want to format it. You have actually free reign to do this, and however you want to do it. And there's a real good reason to do something like this. And then let's do it. So date plus, let's just do %A. Let's just see what happens right here. Tuesday. So %A displays day of the week, right? And if we do comma %B, what does that do? %B is month, right? And it took my comma space literally. Everything in quotes gets taken literally. And then %E, little e, %, comma, space, %, big Y, %, big Z, dash, dash, %I, colon, %M, P. Eh? There you go. The clock is quite literally wrong. But yeah, that's the deal. That is the deal. This is, by the way, if you ask Google what time it is, this is the format that they'll give it to you in. That's why I have this there. Because you can make this say whatever you want, however you want. And then if you do this is a very common format to people that want to run multiple things and have a date as to when it was run. Right? It looks like gibberish, but it's not. 2020 is the year. 02 is the month. 25 is the day. 18 is the hour. 12 is the minute. 26 is the second. What you can do with this is, like, let me see. I didn't think this through. Because now I have to think about it for real. So what you would do is, so what we can do is, let's do copy, what was it, secret file. Oh. And then you can do something like command substitution. What do you think happened? I copied secret file to that dateness stuff. What do you think it did? Any guesses? Now what do you think it did? Let's do this. How about this?
Very good, but
Renee's got it.
is it the date, the time that you can copy?
Yeah, but it did exactly what I told it to, right? So let's read that. Copy secret file to a file named backup dash and whatever the current date and time in this format is. So this is extremely useful because if you copy a file once a second, every file will have a different name. It will get updated by 1 second every single time you copy it. This is not the most useful thing for everyday copying files and stuff like that, but it is useful for keeping track of a daily backup, right? You perform that backup at 6 p.m. every single day. And guess what? You'll have a file with the date and exact time down to the second of when that backup was created. So, really cool information. That is awesome, 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 good stuff. You'll run into that problem, I promise you. It may be on Windows, but you'll at least have the thought process to figure out what's going on. So a lot of times, so hardware clock, system clock. Hardware clock is the thing that your motherboard keeps for you, right? Why you want that stupid little silver battery down in the bottom of your motherboard so it actually keeps time. When you pop it out, the time goes crazy and you don't know what time it is, right? Yeah, that is the hardware clock. The kernel can touch it. What's that? Yes, your CMOS clock. The kernel can interact with that. Most of the time, what you want to do is tell the kernel to go see what the time is on the hardware clock and match the system clock to that. The system clock is Linux's clock or Windows's clock, right? And they can be separate, right? Maybe you have your hardware clock in UTC, but you have your system clock in CST, our time, Texas time, right? You can do that. That's not a problem. Or if you want to go the other way around, if you want to take the system clock and match that up to the hardware clock, right? Like, so you have your system time and it connects to the Google servers and Google tells you what time it is, right? And so you're all day, every day, pinging the Google server. Do I have the right time? Do I have the right time? Do I have the right time? And you don't want to have to reboot to go in there and change the hardware clock to match it up to whatever it is that you do. You just run that command. Hardware clock -S. So basically what you're saying is match the hardware clock to the system clock. Ta-da! And then what I was talking about, I think NTP is already installed here. Oh, there are 20 similar ones. Great. NTP date. Do. Getting there. Cool. Sudo in. Ooh. Let's see if that works. Waiting for some time. Yay! It's right according to UTC. Yeah, I think we're seven hours drift or something like that, or 6 hours drift. Yeah, 6 hours. That's right, because -6, right? That's our time zone. So yeah, that time -6. So I actually did have the right time. It's just all set in UTC. So we would have to do something like time, date, CTL. Set time zone. America, Chicago. 1. There it is. Okay. So I had to change my time zone. The time was right. It was just in the wrong time zone. So anyway, but now my journal will be right. Now my logs will all be right. So time is important. Super duper important. And you can tell your server to say, hey, don't trust yourself. Trust the government. I don't know, tinfoil hat. But right, you can do Google, you can do anybody else, anybody that runs a time server, you can adjust against, and you can have your own. You can set up your own time server if you want, and that way all your computers work off that one time server. Whatever you want to do. Now, there's a service called NTPD that will take care of this for you. It's installed by default on CentOS, but it's not on by default in CentOS. So system control enable NTPD should look a little familiar. NTPD is new, but turn on the service and keep it on at boot. That's how you would do that. And let me see. I don't know if NTP. Zipper. I don't want to have to bring up the CentOS box. That's what I'm trying to avoid right now, because I don't want it to slow everything down. But I don't know what it's called. All right, well, if I don't get it installed, you can do this on your CentOS box here. You can type, after you turn it on, in this case, you have to reboot first. So system control enable NTPD, and then system control start NTPD. And then you can use these commands. NTPQP or NTPQ peers, and that will show you all of the servers that you are currently adjusting your time against, right? And it's happening automatically. And then NTPQ associations will give you even more information about that. And then there's an ntpd.conf file in Etsy that you can configure to tell it which servers you actually want it to use, right? So more often than not, you're really just going to be tested on how do you adjust it right now, and then how do you see who you're going up against. That's the big deal. All right. Here's what I'm going to do. I'm going to blaze through this so that you have the whole video and everything that I need to tell you. And then on Thursday, I want to sit down with you guys, and if some of that didn't stew right and didn't make sense, I want to cover it again. But this way, you'll have it all in the video ready to go, in case you need to go back and look at it. Okay, so obviously NTPD is not what you call it. It might just be called NTP. Okay, so it might be the same for OpenSUSE then. Sure enough. Yeah, like I said, I'm just trying to avoid opening up another VM because I feel like it's going to blow my machine up. But anyway, so logging. We've already kind of taken a look at a log, right? We saw the SSH connection happen. We saw that all happen. Pretty much every log is going to live in var log. cd var log. You can see some of the stuff inside of it if I can actually type. There's the auth log. So cat auth log. You'll probably see the SSH stuff show up, right? So here's the thing, though. It is insane to try and parse each of those logs individually, right? You got dmessage, what we talked about before. You've got auth log. You've got dpackage log. Dpackage. What would that be a log of? Like what? Doing what with them? Installing them, updating them, removing them, doing anything, reconfiguring them, any of that. All that goes into that log. Syslog. Anything that happens to the system itself at a system level. Kernel log, anything that the kernel is doing, right? So you have all of this stuff in var log. That is insane to try and keep track of. So systemd simplified it for you. The way that you get to these things is journalctl. And that starts at the very top. Look at that, January 16. A little old. So I don't want to do that. You want to do E for end. Takes you to the end of the log. This is the most recent stuff. Probably what you want to look at, right? This is all of the important logs dumped into one log, easily searchable, etc., etc., etc. You can grep, but there's a better way to do that. You can grep. That is totally a thing. A lot of times grepping will be done with individual logs themselves. And then journalctl actually has facilities for you to figure all that out. So let's slog through a little bit of this, and I'll show you how to do that. So, right, like common loggings in syslog, yeah, we talked about a little bit of this. ADM, we didn't actually look at ADM itself, the user or the group, but you can see that let me just tell you that ADM is an older construct. It kind of stood for administrator. People were in this group if they needed to be able to do any kind of administrative logging of any kind, like look at those files, delete those files, rotate those files, any of that fun stuff. You were in the ADM group, which is why this holdover exists. But most of the time, it's just there now in syslog. But if you look, the holdover has not ended. Look at this line here. Oh, I'm sorry, the one below it, sorry. And look at the group ownership of that. ADM. What's that? Well, look at the person, I'm sorry, the group that actually owns this. And it's ADM. So the holdover is not fully gone. If you're in that group, you are able to read auth.log. Right? So ADM's not fully gone, but these directories don't really get used anymore. So Logger is super cool in that, let's say that you want a specific phrase to start off like, hey, I'm going to start logging something right now, or this is my starting point, something like that. So you can type in something like Logger beginning of my manual logging. Right, something like that. Oops. Oh, right. Oh, it actually had to do that. So then you can come into, and you can see, look at the very last log entry. It obviously did not like the exclamation points, but it works. And that will be something that you can grep for later, or search for later, right? So instead of having to remember a time, you can just say, let's pretend, right? I didn't hit the shift. It's another way to do it. Give or take. But it's a way to actually put a note for yourself, and then you can search for that again later. So, how do you control this? In the etcrsyslog.conf file, you'll find rules for a lot of this. And this is going to provide you pretty much some of the basics, just like we looked at the sshd.conf _config file. This is going to contain a lot of the rules, the basic rules. But look at that very last line. It says include config etcrsyslog.d *.conf. So what it's telling you there is this is not actually where the meaty rules are. They live in that directory. So let's go there. And you see, UFW, cloud init, and default. Default is where all the meat is. If you add more configuration files, you can add more rules. Or you can just edit what's already there. So let's go into, well, yeah, that's fine. Take a look at that, right? All the blue stuff is not being looked at. But if you look here, messages that have the auth or authpriv prefix go into var log auth log, right? Everything else that has nothing to do with auth and authpriv go into var log syslog. So these are the selectors, right? They look like this. Sometimes they are just everything. Sometimes they're everything with a suffix. Sometimes they're just everything that has .emerge at the end, but nothing at the beginning. So that gets kind of confusing. But know that right here, part before the dot is the type of message. The part after the dot is the severity, right? So you can have authpriv.emerge, right? So emergency level privilege escalations. Anytime you try to authenticate to a, like using sudo, if it's an emergency, only that will be logged. So you can have a whole nother line down here that says auth.emerge and then specify where you want that to be logged. That's all this is. And you can change this to your liking. And distributions do that. Oh, wow, just remote.com. So Ooh, can't even read it. Yeah. There it is. Ooh, God, please no. But, oh wow. So OpenSUSE, of course, has to be different. And they log it somewhere else. Oops. They might just put it straight in Etsy. Oh, did it? Oh, wait. Not D. I can't figure it out. There. Oh, my goodness. One of these days, man. One of these days I'll actually get into this. Here we go. Yeah, there we go. Okay, so we finally get to it. So OpenSys keeps it in rsyslog.conf. Ubuntu keeps it in individual files in rsyslog.d, right? So again, differences between distributions, but the same kind of thing, right? Mail messages go into varlog mail. Informational mail messages go into .info, .warn, .error, right? That's what that is all going to mean. Then you can come in and use tail to follow along with something. So let's look at var log messages real quick. Aw, doesn't have one. Also distribution specific. Ooh, I have an idea. Let's do this. Tail f var log auth log. Let's look at that. And then I want to rerun 325. So line 325 is the SSH as Batman, right? Look, as soon as I did that, look at that. That log popped up, right? And then I'm going to try and look, more lines. Oh yeah, you can do that. Yeah. Right? Failed password. And then do it again. Failed password. Happens automatically, right? So keep an eye on that. And this is the deal. -F stands for follow. So tail, right, looks at the last few lines of any particular file. -F says follow it. So anything new that happens in that file that gets appended to that file, bloop, 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 it'll just show up. It'll just show up. But tail's the old way. Journal CTL is the new way. But the cool thing about that is that it still uses the same option. So journal CTL -F, right? Oh yeah, so it found the Batman thing, but it looks like it's not. Oh, it is. There it is. Yeah, one more authentication failure. One more authentication failure. So it'll try over and over and over again. And it doesn't work. Oh, and look, DHCP happened. So anyway, now, here's what I was talking about. You don't have to grep for it. If you know the service that you're looking for, I want to know about NTPD, or I want to know about apt, or I want to know about, let's look at, let me see, SSHD in this case, right? We can do journal CTL, syslog, if I can spell that right, log, nope, identifier equals SSHD, whoops. Oh my gosh, journal. There we go. This is just SSH stuff. So if I want to follow this, -F at the end of it. Now I am watching in real time as SSH connections come in, go out, stop, start, password authentication, all of it. If it has to do with SSH, I'm looking at it. You can also write it like this. SSHD.service if you want. Or you can specify its path. One of the two. Or three. I'm sorry, one of the three. Either or. I feel like this one's a little easier to remember because you already kind of have those services in your mind when you're trying to start and stop it and all that. And then -U is all you got to remember to follow that. And then just stick an F at the end. Good to go. All right. So the last little bit is rotating. So Oh yeah. So you end up with a lot of different things. Sorry. So before we get to the rotate, you can manjournald.conf. This is the point I was making earlier. How does journald.conf work? There's a manual page for it. Tells you everything, every single option that you would ever run into. It's got it. So, like I said, toilet reading. You can go to I could never remember the name of this website. Linux.die.net. Has every man page that exists. So, go for it. I know you take your phone in there with you. You can make it useful time. All right, so anyway, the last thing is logrotate.conf or logrotate.d. So this is basically, log rotation is basically the idea that you don't want logs to ever be like a gajillion miles long. You want them to stop at the end of the day or stop at the end of the week, get rotated out, and a new log gets placed into its place. That way you can back up logs. Backing up files when they're in use is not the best idea because you might end up with a corrupt file at the end of it, or you might end up with just missing stuff. So in that case, you want to do log rotate and then copy out the logs that you rotate out. That way, you know, you only lose a little bit if you ever lose everything. So in Ubuntu, logrotate.d, everything is inside of here, but there's nothing inside of it. Oh, wait. That's why. That might be why. Yeah. Logrotate.conf. Here we go. So, all the logs that were defined in rsyslog, rsyslog.d before. These are the rules that they follow. Rotated weekly. So every log goes from Sunday to Sunday, and then Sunday at midnight, starting the new day, rotates it out. A file gets pushed off to the side, gets a date tacked onto the end of it, and a new file is created. So, and it right? Keep 4 weeks worth of backlog. So you have 1 month of logs ready to go. You can change that to 8 if you want 2 months, 12 if you want 3 months, right? 50, 2 weeks in a year? If you want a year's worth, right? This, create a new empty log file after rotating old ones. So all of these options here. And then you can come down and specify for this particular log, I want these rules, and you'll do it like that. So var log wtmp brackets, curly brackets, and then new rules. These are the most common rules that you're going to run into. Missing OK. If there wasn't a log before, but there is a log now, that's fine. There doesn't need to be a log there before. Creates a new log file after rotating the old ones. Copy truncate will copy the current log to the new log and copy the current log to the rotated log and then zero out the current log. So what that means is if that file is in use, you can't actually delete it, right? Because someone's using it. So what it does is it copies out all the text to the rotated version of that file, of that log, so the one that's not getting used anymore, copies all that junk to the rotated log, and then deletes everything in the current log, but it never deletes the file itself. Because by default, the file just gets deleted. Moved, deleted, and that's it. And then post-rotate. It's pretty cool. You can run a command after the log is rotated, like mail root. Quotes, log got rotated successfully, whatever, right? Do whatever you want to at that. Post-rotate will allow you to run a command. All right, so like I said, I blazed through all of that, only 7 minutes over. That way we don't have to have a class on Thursday, but I really encourage you guys, because I did go through that fast. If you have questions, please come in and ask. If you can't come in, hit me up on Slack, send me an email, whatever you want. But if this doesn't stew right, don't sit there and just expect that you'll pick it up later on. Ask a question. Ask. I'm not going to bite your head off most of the time. No, I really won't. So anyway, talk to me. This whole thing is a conversation. So I know it was. I blame the new Linux Plus exam. It was all the old stuff as well as a good bit of new stuff. So, yeah. Yep. So security and then logging that security. Stew on that. I expect that y'all will have questions. So please, for the love of God, just ask me those questions.